Okay, those are the questions we want to discuss. So the number one, Adaboosting and random forests are both a bunch of decision trees and why they're different. So the number one is, well, for the Adaboost, usually we only do the depths to be one, so we call them stumps. So, well, that is quite common in Adaboost. Of course, you can do something different, but well, in the most common case, in the Adaboost, we only create the decision trees with only one split in Adaboost. And the second one, for the Adaboost, well, all the trees are created sequentially. So we create one decision tree and then we make the evaluation of the decision tree and then we build the next decision tree to pick up the misclassified samples. And the number three, well, in the Adaboost, after we have n estimators, when we do the prediction, we know the performances of the n predictors. So, well, those predictors are not going to be treated equally. So those are the three differences between Adaboos and decision tree. And the number two, well, the learning rate and the n estimator, there is a trade-off between them. And how do you explain that? So remember for the learning rate. So if you go back, the learning rate controls how fast we want to learn from our mistakes. And if we have a higher learning rate, and probably we are gonna move on better, move faster to pick up the misclassified samples. And in this case, probably we don't need a lot of the estimators. And however, we just learn very slowly on the right side. If we learn super slowly for each iteration, we only pick up a few misclassified samples and then next round we pick up a few more and then we may have to go further with more iterations to pick up the misclassified samples. For example, those blue dots in this area, we may have to go 30, 40 iterations before we can really have even the first classifier to pick them up, right? So in this case, with a lower learning rate, we definitely want to have more estimators. So you may ask, why do we have a lower learning rates? Why do we always make the learning rates super fast? And making the learning rate super high is not really a good idea because when you are trying to pick up the misclassified sample and you try that really hard, and what will happen? So in the first round, you got nine samples correctly classified and you only miss one, and in the next round you tried super hard to pick up the only one misclassified sample, and then as a result you may got all the remaining nine of the samples wrong. So in this case, there's no point to try super hard to pick up one, but leave the remaining nine of them all misclassified, right? So usually, if the computational power is not a big issue, we don't want to try a super high learning rate. Of course, we don't want the learning rate to be super low, otherwise we are creating hundreds of the estimators that may take a lot of time. Okay, so the next question, which one is more sensitive to noise data, Adaboost or random forest? So the answer for this question should be Adaboost. In the Adaboost, if we have just one noise, okay, let's assume that we have two beautiful classes and they're easy to classify. However, if we have just one noise data, and then this may really bother the Adaboost model a lot because Adaboost will try very hard to just pick that one correctly, and eventually you may end up with a weird Adaboost classifier. So before you decide if you really want to use Adaboost or not, well, try to get some sense of your data or do some exploratory data analysis with visualizations so you can get some idea on how clean or how beautiful this dataset is before you decide whether you want to do a decision tree or you want to do a Adaboost. Okay? So the next part, we are going to use the long data as an example again, and below the data, and we know on the purpose that is a categorical column, and we want to get dummies to so that we apply the one hot encoder, and after that, well, oops, I shouldn't show you the answer key. Okay, and after that, well, you should make a random forest model and then evaluate the performance and show the confusion matrix. And the next part, you create another Adaboost classifier, and then you try to do the same thing again and try to compare the performances of those two. And based on what I got, it seemed that for this dataset, since this is not balanced at all, and you may get the second class wrong a lot, and no worries. Well, this is because we have an imbalanced dataset. So try to write the code for a random forest and the Adaboost, and after you finish coding, come back to my next video and I will show you my answer keys there. Okay, so see you later.